Hello everyone. My name is Michael Chen, and I'll be presenting for the EPS team. So, just a quick overview of our team. We are a group of uh, most. We are a group of engineers, mainly engineers. A lot of engineering physics. We have some in ECE and in mechatronics. Just a quick overview of our system. So we sit down here on the bottom of the stack, and we mainly just collect power from the sun using the solar arrays and cells, and then we store that on the battery, which is housed over here on the PDM, which is the actual physical board that holds the battery and helps distributes and regulates the power. So a little bit about the actual EPS board that we're using. It is a commercial off-the-shelf system, or COTS, with flight heritage, which means it's extremely expensive. And as mentioned before, some of its functionalities are to control the power distribution and battery charging as well. And included from the manufacturer is a set of preset commands that we can use to help code the system. So how do we collect the actual power from the sun? So we have solar panels that we designed in-house, and then we attach cells, which we buy from that aren't shown here, but would go in these slots over here, and they would be connected via these panels to the PDM directly. So just some things to note about these panels is because these will seal up the satellite completely, we'll still need to access the satellite. So we still might need to access the boards when we're testing it, for example, in a TVAC chamber. And we can do that via the umbilical connector over here on the bottom left. And because of certain requirements from NASA and NEUtron, which are the people who help fly the boards, we will need a remove before flight pin, and that would go over here. And some other tasks that we are working on would be a solar panel simulator, because as you would imagine, the solar cells that we're using are quite expensive. So we don't really want to risk that when we're testing the system. And it will be quite difficult to simulate the actual illumination that would be in AM0 in actual on Earth testing. So we have these solar panel simulators, which is open source hardware and software that we found online. And what they do is they simulate how the panels will act during an actual orbit when we provide orbital data for it. And we can use these during testing to simulate how the panels will act. That way we can basically do a complete dry run on the ground. And in addition to that, we're also to help test the panels themselves. We're going to fly on a balloon mission, as mentioned earlier. But in order to do that, we have designed our own power distribution module for it. And this also, and because it uses similar architecture to the actual COT systems, we can test our software on this too. So yeah, I think we're doing questions later or after this. So if you have any questions, feel free to ask that during that.